Okay, we are ready to do problem 18 out of the text. We're in section 10.4. This is Business Math 2 or Business Calculus, Math 13-16. And we're going to look at problem 18. Now, I'm going to assign you several problems like this one. And what makes these the challenge is that you have to find the function that you want to then find the minimum or maximum value for. It's not just given to you. The type of problem I'm going to show you, I've given you a couple in the assignment that I want you to do. And again, if you can't figure out from looking at this example, from looking at the examples in the text, he does several of them. Let me look in the text and tell you for this particular type of problem, look at example 2. It's a very good example. And perhaps example 5. And then look at the way that I do this one, so that you will know how to do problem 17 that I'm going to assign, problem 15, and problem 19 as well. So how do you put together the problem? We're doing problem 18. In the text, the book says that we have a tract of land from which we're going to take and divide into two parts. It's a rectangular plot of land. It looks something like this. And I'm going to take this plot of land and divide it into two parts. And some of the criteria that are given to us about this particular plot of land is we're going to build a fence around it, all the way around the outside, and then this divider down the middle. And we've got different costs. The outside fence cost, I think it's $5 per foot to build, and the inside fence costs $2 per foot. This would typically happen if you're maybe required, maybe you're trying to keep, well, you just need a stronger fence on the outside than you do dividing in the middle. For whatever purposes you're going to use the plot for. So the outside costs $5, the inside fence, and that would be this strip right here, costs $2 per foot. What we're ultimately going to want to do is to find the minimum cost to build this fence. And some of the criteria that we have is we know that the area of each of these inside plots needs to be 13,000 square feet of area. 13,500 square feet. Now, how in the world did I come up with an equation to represent all these? And I can just tell you that ultimately what you're going to want to do is represent the, say the length of this section X, and then call it the length or the height or the depth of the area, doesn't matter. Notice if I call this L, it's going to be the same here, here, and here. But we have not yet learned how to maximize a function or minimize a function or find critical values for a function that has more than one variable. And so my job here is to try to find a way to let X represent the length of this section from here to here, to represent all the other lengths, distances on there, amounts of fence that I'm going to use in terms of X. And so the fact that I need each of these inner plots to have an area of 13,500 square feet is the way that I'm going to do that. The way that I get the area of this inner plot is going to be X times L. And I know that I want this area to be 13,500 square feet. Well, see, I can take this equation and I can solve for L in terms of X, divide both sides by X. And I get L is equal to 13,500 over X. X is canceled here. L is equal to 13,500 divided by X. And so that's real helpful. That tells me that this length right here, I pick X to be this distance from this part of the fence to this part. That forces the height and depth of the length of the field to be 13,500 over X because of this restriction, this requirement. This is so very typical of all the problems like this that we're going to do. You're going to be given some restrictions. You're going to be given something that you want to maximize or minimize. You need to come up with a function for what you want to maximize or minimize. And you'll do that by drawing a picture like I've done and finding something that's given to you in the requirements of the problem that allow you to solve for this side in terms of your variable x. Okay, now, I'm going to do some thinking. If this distance is x, this one is as well, because both of these are going to have the same area of 13,500 square feet. And so what I need to come up with now is a function, a cost function, to build these fences to get this area plotted out like this. Okay. Now, what I'm going to do is I'm going to build fence. You know, from here to here is going to be, I have x feet here, I have x feet here. So the whole distance from this edge to this edge is 2x feet. This distance as well. Then it would be 2x feet because it's a rectangular plot. And so what would my cost C of x be? Well, remember the outside fence costs $5 per foot, and so it's going to be $5 times how many feet on the outside. Well, that's going to be 2x plus 2x to get this distance and this distance. And then it's going to be plus this plus this. So plus 13,500 over x plus 13,500 over x. Now, I'm not trying to be formal or quick or smart or anything else. I just want something that I can understand where everything came from. It gives me the cost of the fence. Now, what I've done right here is I looked at all the fence on the outside part of the plot. It's going to cost me $5 per foot. And I put $5 times however many feet. And the number of feet I have on the outside is 2x plus 2x, these two parts. And I have L plus L, or 13,500 over x plus 13,500 over x. Now, what about the inside part of the fence? Well, that's just this one section right here. And it's going to be $2 times, well, what is this length right here? Well, it's the same as L. It's 13,500 over x. So that's a rough draft of my cost function. All I want to do is combine my terms and simplify that a little bit. So C of x is going to be 5 times 2x plus 2x would be 4x. You know, if I have 13,500 over x plus 13,500 over x, I have a common denominator. So just add the numerators. So that would be 27,000 over x. And 2 times 13,500 would be 27,000 over x. Multiply 5 by each of these terms. I'm gonna erase my picture here because I don't think I need it again. Again, you can always stop and replay the video, back up, get a screen print, or just write down anything you need to see. So I'm going to keep developing my cost function here. I'm going to leave room at the top to put my simplified version of it. So I've got 20x, 5 times 4x gives me 20x. 5 times 27,000, just use a calculator, that'd be 135,000. Over x plus 27,000 over x. And finally, I can combine these two terms, and that would be 162,000. So my final cost function is going to be 20x plus 162,000 over x. Now, on the last example that I did, the previous video for problem number, forget which one I did, 14, problem 14. What I suggested is once you have a function that you want to maximize or minimize, make a chart, a table. Put this function into your calculator and get some value so that you have a good mental picture of what's going on. I'm going to erase all of this work, and I'm going to build that chart. Because, see, what this farmer, rancher, or whoever it is, owner of the property, is interested in is I have a plot that I need to divide into a rectangular plot. I'm going to divide it into 2 parts, each part of which must have 13,500 square feet. For whatever reason, I'm going to plant a crop, and I know I need that many square feet to get what I want out of the crop. But this is what it's going to cost me if x is how many feet. Remember my picture? X is this distance right here. If I choose that distance x, this tells me what my what my cost to build all the fences are going to be. And so let's make a chart, X and C of X here. And you know, you've got to let X equal something. And let's just take some small numbers like 10 feet for this distance X, which would be 20. You know, this whole distance here is 2X, so it would be 20 feet. And remember, this is 13,500 over X. So let's let X be 20 feet, 10 feet, 20 feet, 30 feet, 50 feet, 100 feet. Now, until I actually plug some numbers in and see what results I'm getting, I don't have a clue what this is going to be. One thing that might be interesting to do is when you pick a number X, just note what the dimensions of your property would be. You know, X is this distance right here, 2X would be the whole length, and 13,500X would be the height or depth of it. I'm going to enter this function into my calculator. And we've done this in class, and you know how to do it. So I've got 20 times X plus 162,000 divided by X. What if I let X equal 10? If I evaluate the function, my cost ends up being $16,400. And let's think about what we've done. If X is 10, then this distance is 10, this distance is 20, and this distance would be 13,500 divided by 10 would end up being 1,350, 1,350 feet. So what we've got a field that is 20 feet wide by 1,300 feet long, and that's going to take a lot of fencing material to fence. So that's a poor choice, but that's what it tells us. Okay, what if I let X equal 20 feet? And evaluate that in my function. If X is 20, then my cost is going to be $8,500. And again, if X is 20, then my total width of my field, or width, is going to be 40 feet. And this would be 13,500 divided by 20. Would be 675 feet. So again, the problem we've got is I need this to be, you know, more equal in terms of the total width here and the total height or depth or length right there. And so let's get some more functional values. If X is 30 feet, then my cost comes out to be $6,000. If X is 50 feet, my cost comes out to $42.40. If X is 100 feet, my cost is $36.20. What if X is 150 feet? That's $36.20. $4,080. Now I want you to notice something. When I let X equal 120 feet, or 150 feet, that caused my cost to go up from the previous entry. So what we've noted right here is that somewhere between 50 and 150 feet, the dimensions to let X equal, I'm going to have a minimum cost. And my job now, see, this was solely for the purpose of getting a handle on the problem, understanding what's going on. My job is to figure out what is the dimension to use for X to get the minimum cost for my fence. And so I'm going to erase my table, and I'm going to start using calculus to do that. And everybody, you know what we're going to do. We're going to take the first derivative of my cost function, and I'm going to find a critical point, and I'm going to find which of those critical points gives me a minimum value for the cost. So let's take our derivative. Let me point out to you one thing we're going to do. I think you knew this. I will think of this function written in a slightly different form, so that when I take my derivative, right here I use the power rule, and it's just easy to look at that and see what to do. So my derivative, the derivative of 20x is going to be 20. Right here I'm going to take my negative 1 times this coefficient, and then subtract 1 from the power, from the exponent. So I get 162,000 times x to the negative 2. And in order to evaluate it, you've got that written down, just like this. Like so. And so you may want to evaluate the derivative so that when we make a sign graph to test regions, you'll know if the derivative at any given x is positive or negative. Now, what I need to do is find critical points, and the way I'm going to do that is set this equation, or this function, equal to 0. Now, there's any number of ways that you can do this. You could multiply this by x squared and x squared, and have your equation is equal to 0, and that would work. But anytime all you have is a single x squared, you have a constant here. Let's subtract 20 from both sides, or add negative 20 to both sides. Let's cross multiply. And so we're going to end up with x squared here is equal to 162,000 divided by 20. It's 8,100. Now, I'm a little concerned about I lost some people going from this step to this step. Let me write this down and show you a few more steps that I'm doing. Here's what I did. You want the x squared to be at the top, so multiply both sides by x squared over x squared, or multiply both sides of this equation by x squared. That causes the x squared here and the x squared here to cancel, and that leaves you with negative 162,000 is equal to, that should have been I don't know if you remember, negative 20, when I add negative 20 to both sides. And so you end up with negative 162,000 equals negative 20 times x squared. Divide both sides by negative 20. And that'll give you, those will cancel. And that gives you your x squared. And 162,000 negative divided by negative 20 is positive 8,100. So that's how I got from where I was to this. You can pause or get a copy of that or do what you need to do. And so if I have x squared is equal to 8,100, take the square root of both sides. X is equal to plus or minus the square root of 8,100. And that's 90. So my critical point, the solution when I set this equation equal to 0, the solution to that is positive or negative 90. Now again, this is a real world problem. We actually have another critical value. Notice in this derivative, if x is equal to 0, this is undefined, and so you also have a critical point at 0. So I am going to make a sign graph to test and make sure that positive 90 is a minimum value. But I know from, you remember my chart that I made before, that that's going to be a minimum value. I'll go ahead and real quick make a sign chart. So here's my critical points, my CPs. X is equal to negative 90, 0, and 90. The negative 90 and the 90 come from the solution to setting this equal to 0. The 0 comes from it being undefined. X is equal to 0. Make a sign graph. You have x, you have c prime, you have c. Negative 90, 0, and 90. If I plug a number into this like a million squared is going to be a very big number. 162,000 divided by a billion is like close to 0. So I have 20 minus 0 is a positive number. And that means my function is increasing there. If you do not like my type of reasoning to figure out if this is positive or negative as a given x for all the x's in these regions, just put this into your calculator, plug a number like 91 into that and see what you get. And that'll work. If I take a number in this region like 1, if I put 1 in for x, I have 20 minus 162,000. That's going to be a negative number. Right, if I put negative 1, it would be negative 1 squared, so it would be positive 1. And that would be negative, and back here would be positive. Again, all of this from here back does not matter because x is going to be a positive number of feet that we're going to choose from that dimension of my plot. The key thing is the function c is decreasing for x is up to 90, and it's increasing after, so it's going down, and it's going up, And that means my cost is going to be minimum when I let the dimension x equal 90. And so if x is 90, I need to find c of x. Plug it into this equation. You've got that in your calculator, and evaluate it when x is 90. And you get $3,600. So you have minimum cost for the fence of $3,600 when x is 90. We might go back to our original picture. You know, what dimensions does that give me for my field? Well, x, this is going to be 90. This is 90. So it's going to have a length of 180 feet. What is this width going to be right here? Remember, it was 13,500 divided by 90. And let's see what the, I'm curious what the depth of the height of it would be. And we get 150 feet. So this distance right here is 150 feet. So if it costs you $5 per foot to construct the fence on the outside and $2 on the inside, these are the dimensions that would give you the minimum cost for your fence. And what a great problem. You know, how would you figure that out? I guess trial and error you could, but calculus is a great way to do it. Now you're going to work problems 17 and 19 and 15, and you'll have to do something very similar to what I've done here to create your cost function. And the key to doing that, you're going to have two dimensions, and you need to find a way to express both of those dimensions in one variable, x. Okay, I will put the assignment on the website and just say to you, good luck. Work hard on this. We'll have a couple problems like this on the midterm. Monday, I will review. I'll put some midterm problems for review. One thing you can always do is review your quizzes, your previous quizzes. Make sure you can do any of those. Any of the homework that I assigned for each of those assignments, make sure you can do any of those. And I'll pick some problems out of the chapter review and chapter test as well. I'll answer questions on the problems from 10.4 on Monday, and we'll take our midterm exam a week from today, next Wednesday. Good luck, and isn't it a great day to be alive and studying business?